What if the silence of the night sky isn't silence at all? What if, hidden in the vast darkness between the stars, there are whispers we haven't yet learned to hear? For centuries, humanity has gazed upward, wondering if we are the only ones asking these questions. The universe stretches beyond imagination, with billions of galaxies, each holding billions of stars, and around those stars, countless worlds. The numbers alone suggest we can't possibly be alone, yet the cosmos remains quiet, or so it seems. This is the mystery that drives the search for extraterrestrial intelligence, or SETI, a scientific quest to find answers among the stars. Imagine telescopes listening like cosmic ears, scanning the heavens for a signal, a sign, anything that might tell us we're not the only ones dreaming under this infinite sky. Tonight, let's drift into that wonder, where science meets the unknown, and the question lingers like a gentle hum in the dark. Are we truly alone? But here's the puzzle that keeps scientists awake at night. If the universe is so unimaginably vast, and the odds of life seem so high, why haven't we found any trace of it? This is the heart of what we call the Fermi Paradox, named after the brilliant physicist Enrico Fermi, who once sat down to lunch with colleagues and asked a simple, haunting question: where is everybody? Think about it. Our galaxy alone holds hundreds of billions of stars, many with planets just right for life. Even if civilizations are rare, the sheer number of worlds should mean we're not the only ones. And yet, the cosmos is silent. No signals, no visitors, no signs of distant cities glowing in the dark. It's as if the universe is a stage set for a play, but the actors never arrive. Some say maybe we're looking in the wrong way, or maybe advanced civilizations hide themselves. Others wonder if life is far more fragile than we think, vanishing before it ever gets the chance to reach out. Or perhaps, just perhaps, we truly are alone, a single spark of awareness in an endless sea of stars. Whatever the answer, the Fermi Paradox reminds us that the universe keeps its secrets close, leaving us to wonder in the quiet between the stars. Now, let's turn our gaze to a different kind of cosmic puzzle, one that tries to put numbers to the mystery. In the early 1960s, astronomer Frank Drake sat down and wrote out an equation, a simple yet profound way to estimate how many civilizations might be out there, waiting to be found. The Drake equation isn't some complicated math meant only for scientists. Think of it more like a recipe, with each ingredient representing a piece of the grand question: are we alone? The first ingredient is the rate at which stars are born in our galaxy. Picture the Milky Way as a vast, slow-burning fire, with new stars flickering to life every year. Next, we consider how many of those stars have planets. Not so long ago, we didn't know if other stars even had worlds beyond our solar system. Now, we've found thousands, and it's clear planets are everywhere. Then comes the fraction of those planets that could cradle life. Not too hot, not too cold, but just right. What we call the Goldilocks zone. After that, we ask how many of those suitable worlds actually develop life. Maybe it's common, bubbling up wherever there's water and warmth. Or maybe it's a rare spark in the dark. The next step is even trickier. How often does life grow into intelligence? Does every planet with microbes eventually produce thinkers, builders, dreamers? And of those, how many develop the technology to reach out, to send signals we might hear? Finally, there's the last variable, the length of time these civilizations might last. Do they flourish for millennia, broadcasting their presence to the stars, or do they vanish too quickly, leaving only silence behind? Drake's equation doesn't give us a single answer. Instead, it's a mirror, reflecting how much we still don't know. Some fill it with optimism, suggesting the galaxy hums with voices. Others plug in numbers that leave us solitary. But either way, it reminds us that the search isn't just about finding aliens. It's about understanding our place in the story of the universe. But before the Drake equation could even be tested, someone had to take the first step, to actually listen. And so, in the spring of 1960, a small team of astronomers pointed a radio telescope toward two nearby stars, their fingers hovering over the record button, their ears tuned to the static of the cosmos. This was Project Ozma, named after the queen of the fictional land of Oz, a place as distant and mysterious as the worlds they hoped to find. The telescope, nestled in the hills of West Virginia, focused on Tau Ceti and Epsilon Eridani, two sun-like stars just a dozen light-years away. Night after night, the scientists listened, straining to catch anything that didn't sound like the usual cosmic noise. A pattern, a pulse, anything that might say, "We're here." Imagine the quiet of those pre-dawn hours, the hum of machinery, the coffee going cold as they leaned closer to the speakers. Every blip or buzz sent hearts racing. Was this it? The answer humanity had waited millennia for, but each time it turned out to be a passing satellite, a glitch, or just the murmur of the universe itself. Project Ozma didn't find any signals, not then, not in the follow-up searches, but it did something just as important. It proved we were willing to look. That we could turn our curiosity into action, our equations into antennas. And though those early efforts seem quaint now, with their simple equipment and narrow focus, they lit the path for everything that came after. Because sometimes the bravest thing you can do is listen, even when the stars stay silent. But the stars weren't done teasing us. Years after Project Ozma, on a quiet August evening in 1977, the universe sent us a whisper, one so strange, so fleeting, that it still haunts astronomers today. The Big Ear Radio Telescope in Ohio, a humble setup with a dish the size of a football field, was scanning the sky when it caught something extraordinary. A signal burst onto the printout, so strong and precise that the scientist reviewing the data, Jerry Amon, circled it in red ink and scribbled a single word beside it: "Wow." For 72 seconds, this signal blazed from the direction of the constellation Sagittarius, pulsing at a frequency that natural cosmic phenomena rarely produce. It was the kind of signal you'd expect if an intelligent civilization were deliberately broadcasting into the void. The team scrambled to listen again, pointing their telescope back to the same patch of sky, straining to hear even the faintest echo. But the signal never returned. Decades later, we still don't know what caused it. Was it a passing comet reflecting radio waves? A glitch in the equipment? Or something far more thrilling, a cosmic hello that slipped through our fingers. The wow signal remains a tantalizing mystery, a single note in an otherwise silent symphony. It's proof that the universe can still surprise us, that even in the quietest corners of space, there are stories waiting to be heard. And maybe, just maybe, one of those stories belongs to someone else. Today, the search for extraterrestrial intelligence has grown far beyond the humble beginnings of Project Ozma or the fleeting mystery of the wow signal. With technology advancing at an astonishing pace, modern SETI initiatives are scanning the cosmos on a scale that would have been unimaginable just a few decades ago. One of the most ambitious efforts is Breakthrough Listen, a project that harnesses the power of some of the world's most advanced telescopes to listen for signals across millions of stars. Imagine a cosmic eavesdropper patiently sifting through the static of the universe, searching for that one faint whisper that doesn't belong. Breakthrough Listen does just that, using facilities like the Green Bank Telescope in West Virginia and the Parkes Observatory in Australia to scan vast swaths of the sky. These instruments are so sensitive they could detect a signal as faint as a cell phone transmission from a nearby star. The project doesn't just focus on radio waves, it also looks for laser pulses, another potential signature of advanced civilizations. But here's the thing about searching for extraterrestrial intelligence. It's not just about having the right tools, it's about endurance. The universe is vast, and the odds of stumbling upon a signal are slim. Scientists must comb through mountains of data, separating natural cosmic noise from anything that might hint at intelligence. It's a slow, meticulous process, one that requires both cutting-edge technology and an almost meditative patience. And yet, the search continues, fueled by the same curiosity that drove Frank Drake and his team all those years ago. Every scan, every analysis is a step closer to answering that age-old question: are we alone? Whether the answer comes tomorrow or a century from now, the pursuit itself is a testament to humanity's unshakable wonder about our place in the cosmos. But the search for extraterrestrial intelligence isn't limited to radio waves alone. Scientists have expanded their hunt to include something called technosignatures, clues that could reveal the presence of advanced technology out there in the cosmos. Think of it like this: if an alien civilization has mastered engineering far beyond our own, they might leave behind fingerprints we can detect, even from light years away. One of the most fascinating ideas is the Dyson sphere, a hypothetical megastructure built around a star to harness its energy. Imagine a civilization so advanced that they've wrapped their sun in a vast network of solar panels, capturing nearly all its light. To us, that star might appear strangely dim or flicker in unusual ways, a potential red flag for astronomers scanning the skies. Then there's the search for laser pulses. While radio waves have long been the go-to for SETI, focused beams of light could be an even more efficient way for advanced beings to communicate across interstellar distances. Projects like Breakthrough Listen aren't just listening, they're watching, scanning for brief, intense flashes of light that don't match any known cosmic phenomenon. And what about artificial chemicals in a planet's atmosphere? Imagine detecting signs of pollution or industrial byproducts on a distant world, evidence that someone or something is altering their environment on a massive scale. Even the heat signatures of massive cities or orbital habitats could, in theory, be spotted with powerful enough telescopes. The beauty of technosignatures is that they force us to think bigger. If extraterrestrial civilizations exist, some might be so far ahead of us that their technology would seem like magic. Searching for these cosmic breadcrumbs isn't just about finding life, it's about glimpsing the future humanity itself might one day reach. And that possibility, however distant, keeps the search alive with a sense of awe and endless curiosity. Now, let's turn our gaze to the stars, not just as points of light, but as suns that might host worlds of their own. Over the past few decades, astronomers have uncovered thousands of exoplanets, planets orbiting distant stars, and among them are those that sit in what we call the Goldilocks zone. This is the sweet spot around a star where conditions are just right. Not too hot, not too cold for liquid water to exist on a planet's surface. And where there's water, there's the tantalizing possibility of life. Picture a world bathed in the gentle glow of its star, with oceans shimmering under alien skies. Some of these planets might be rocky, like Earth, while others could be vast water worlds, their surfaces entirely covered by deep, endless seas. Then there are the super-Earths, larger than our home, but smaller than gas giants, with atmospheres thick enough to trap heat, yet thin enough to let sunlight through. Each one is a puzzle, a potential cradle for life, waiting to be understood. The discovery of these worlds has transformed the search for extraterrestrial intelligence. No longer are we guessing whether planets exist beyond our solar system. We know they're out there, in staggering numbers. Telescopes like Kepler and TESS have been our eyes in the cosmic dark, spotting the faint dips in starlight as planets pass in front of their suns. And with every new detection, the question grows louder. If so many planets exist, how many might harbor life? Some of these distant worlds orbit red dwarfs, stars smaller and cooler than our sun, where the Goldilocks zone is much closer in. Others circle stars like ours, their years measured in Earth-like seasons. A few even wander alone in the void, rogue planets untethered to any star, their surfaces frozen, but their subsurface oceans possibly warmed by geothermal heat. The variety is breathtaking, a reminder that the universe loves to experiment. As we continue to find more of these planets, the next step is to study their atmospheres. Future telescopes, like the James Webb Space Telescope, will analyze the light filtering through their skies, hunting for signs of oxygen, methane, or even industrial gases, hints that we're not the only ones looking up and wondering. The search for life isn't just about listening for signals anymore. It's about reading the stories written in the air of distant worlds, stories that might one day tell us we're not alone. But while we dream of distant worlds, let's not forget the mysteries right in our cosmic backyard. Mars, our rusty red neighbor, has long captured our imagination as a place where life might have once taken hold. Today, missions like the Perseverance rover are combing the dusty surface of Jezero Crater, an ancient lake bed, searching for signs of past microbial life. Imagine tiny fossils, preserved in rock for billions of years, whispering secrets of a time when Mars was wet and warm. This search is different from scanning the stars for intelligent signals. Here, we're hunting for the faintest traces of life, the kind that thrived in ponds and riverbeds before Mars turned to dust. Perseverance drills into rocks, collecting samples that might one day return to Earth, carrying answers in their grains. It's a patient, meticulous quest, one that reminds us life doesn't need to be advanced to be profound. Even a single-celled organism, long gone, would rewrite our understanding of life's reach. Yet, Mars also teaches us humility. Despite decades of exploration, from Vikings' early experiments to Curiosity's chemical sleuthing, we've found no definitive proof. The planet teases us with hints: methane spikes that come and go, minerals that form in water, even strange shapes in rocks that look eerily familiar. But science demands certainty, and so the search continues, a reminder that the universe guards its secrets closely. What makes Mars so compelling is its duality. It's both a mirror and a contrast to Earth, a world that might have once been like ours but took a different path. If life did arise there, only to fade, it raises haunting questions. Is life fragile, snuffed out by cosmic chance? Or is it tenacious, hiding beneath the surface in briny pockets, waiting to be found? These questions ground the search for extraterrestrial intelligence in something tangible. Before we find civilizations among the stars, we might first discover their ancestors in the soil of Mars. And so, as Perseverance rolls across the rust-colored plains, it bridges two great quests. One, to uncover our solar system's hidden history. The other, to understand whether life is a cosmic fluke or an inevitability. The answers, if they come, won't just tell us about Mars. They'll tell us about ourselves and our place in a universe that might be far more alive than we ever dared to hope. But while Mars offers tantalizing clues about life's past, there are other worlds in our solar system where life might still exist today, hidden beneath thick shells of ice. Far beyond the warmth of the sun, orbiting Jupiter and Saturn, two frozen moons hold secrets that could redefine our search for life. Europa, Jupiter's smooth, cracked moon, looks like a marble streaked with rust. Its surface is a maze of icy ridges and fractures, but beneath that frozen crust lies an ocean, one that could hold twice as much water as all of Earth's seas combined. Imagine diving into those dark, salty depths, where hydrothermal vents might churn warmth into the water, just as they do in Earth's deepest oceans. On our planet, such vents teem with life-blind shrimp, giant tube worms, entire ecosystems thriving without sunlight. Could Europa's hidden ocean host similar marvels? Then there's Enceladus, Saturn's small but spectacular moon. At first glance, it seems unremarkable, a tiny, glittering ball of ice. But Enceladus has a surprise. Geysers blast from its south pole, shooting plumes of water vapor and organic molecules hundreds of miles into space. These jets are like cosmic sprinklers, fed by a global ocean beneath the ice. When the Cassini spacecraft flew through these plumes, it detected ingredients for life: salts, silica, even simple organic compounds. It's as if Enceladus is whispering, "Look closer." What makes these moons so extraordinary is their defiance. They are far from the sun's warmth, yet they are anything but dead. Tidal forces from their giant parent planets stretch and squeeze them, generating enough heat to keep their oceans liquid. In Europa's case, that heat might even create underwater volcanoes, stirring the waters with energy. On Enceladus, the ice shell is thinner, with cracks that let the ocean breathe into space. Both moons challenge our assumptions about where life can thrive. The beauty of these worlds isn't just in their potential, it's in their mystery. Europa's icy surface reflects sunlight like a mirror, while Enceladus's plumes sparkle against the blackness of space. They remind us that life, if it exists there, wouldn't need sunlight or open air. It could flourish in darkness, sustained by chemistry and movement, rewriting the rules of biology as we know them. Upcoming missions like Europa Clipper aim to answer these questions. By skimming Europa's surface, it could analyze those plumes, tasting the ocean without ever drilling through the ice. And who knows, one day, a submarine might melt through that icy crust, descending into an alien sea where something, maybe even something wondrous, is waiting. Until then, these moons linger in our imagination, frozen enigmas holding the promise that life might not just be out there, it could be closer than we think. But while Europa and Enceladus show us where life might hide today, there's another possibility, one that stretches across the cosmos like a grand cosmic dance. Picture this: tiny building blocks of life, no bigger than specks of dust, clinging to the surface of an asteroid or nestled deep inside a comet. These microscopic hitchhikers survive the freezing void of space, protected by layers of ice and rock. When their wandering home collides with a new world, they tumble into alien oceans or scatter across fresh soil, carrying with them the potential to spark life all over again. This is the panspermia theory, the idea that life doesn't always begin on the planet where it thrives. Instead, it might travel between worlds, spreading like seeds on the wind. Imagine a dandelion's fluff drifting on a breeze, but on an unimaginable scale. A single impact could launch life-bearing rocks from one planet to another, or even between star systems. Some scientists believe Earth itself might have been seeded this way, with the first organisms arriving aboard a meteorite billions of years ago. The beauty of this idea lies in its simplicity. Life, once it begins, could be incredibly tough. We've seen microbes survive the vacuum of space, clinging to the outside of the International Space Station. Certain bacteria can endure extreme radiation, freezing temperatures, and years without water. If these resilient little travelers can hitch a ride inside a space rock, why couldn't they journey between worlds? And the evidence is tantalizing. Meteorites found on Earth contain amino acids, the building blocks of proteins. Some even have sugars and molecules that could form cell membranes. These space rocks didn't create life, but they carried the ingredients, like cosmic grocery bags dropped on our doorstep. If this happened here, it could have happened elsewhere, turning the galaxy into a vast network of life, sharing worlds. Panspermia doesn't answer how life began, only how it might spread, but it paints a breathtaking picture, a universe where life isn't confined to single planets. Instead, it leaps from world to world, carried by comets and asteroids, thriving wherever conditions allow. Maybe the same microbes that sparked life on Earth also drifted to Europa's hidden ocean or Enceladus's icy plumes. Maybe we're all connected, not just by stardust, but by something even more extraordinary, the shared spark of life itself, journeying across the stars. Now, let's turn our gaze from the microscopic travelers of panspermia to something far more visible, yet equally mysterious. For decades, the skies have been filled with reports of unidentified flying objects, or UFOs, and more recently, what scientists call unidentified aerial phenomena, UAP. These fleeting lights and strange shapes have captured our imaginations, sparking everything from wild conspiracy theories to serious government investigations. The fascination with UFOs is as old as human curiosity itself. Ancient texts describe fiery chariots in the heavens, while modern pilots report objects moving in ways that defy physics. But here's the key difference today. We're not just swapping stories over campfires. Governments and researchers are now collecting data, analyzing radar tracks, and even declassifying footage of these encounters. The goal isn't to prove aliens are visiting us, but to understand what's truly happening in our skies. Take the U.S. military's 2021 report, for example. It confirmed that many UAP sightings remain unexplained, but it also emphasized that most have mundane explanations: drones, weather balloons, or optical illusions. A handful, though, exhibit movements or speeds that challenge our current understanding of technology. That's where science steps in. Instead of jumping to extraterrestrial conclusions, researchers ask simpler questions. Could this be secret military tech? A natural atmospheric phenomenon we haven't fully studied, or perhaps a sensor glitch? This shift from myth to method is crucial. While pop culture loves to paint UFOs as proof of alien visitors, scientists approach them with cautious curiosity. Projects like Harvard's Galileo Initiative aim to study UAPs with rigorous tools: high-resolution cameras, spectrometers, and AI analysis to separate signal from noise. The truth might be less dramatic than Hollywood's version, but it's no less fascinating. Imagine discovering a new type of plasma behavior in the upper atmosphere, or stumbling upon a stealth drone from an unknown origin. Either outcome would reshape our understanding of the world. So where does that leave the idea of alien visitors? The honest answer is, we don't know. But the scientific approach gives us a roadmap. Instead of chasing shadows, we're building a framework to study the unexplained systematically, and that's how mysteries become discoveries. Whether UAPs turn out to be advanced human tech, rare natural events, or something even more extraordinary, one thing's certain: the sky is full of puzzles waiting to be solved. And that's a thrilling thought all on its own. Now, let's drift from the skies above us to the stories that have taken root in our minds, the tales of alien abductions. These accounts, like the famous story of Betty and Barney Hill in the 1960s, have woven themselves into the fabric of modern folklore. The Hills claim to have been taken aboard a strange craft by beings not of this world, an experience that left them with lost time and fragmented memories. Their story, and others like it, captivate us not because they offer proof of extraterrestrial life, but because they reveal something just as intriguing: the power of human imagination. These narratives often follow familiar patterns: bright lights, missing hours, and encounters with otherworldly figures. Psychologists point out how these experiences can sometimes overlap with sleep paralysis, a state where the mind is awake, but the body remains frozen, often accompanied by vivid hallucinations. Others suggest that cultural influences, movies, books, and even news reports, shape how people interpret unusual or unsettling events. The line between memory and imagination can blur, especially under stress or fear. That's not to dismiss these stories outright. They matter because they reflect our deepest curiosities and anxieties about the unknown. When Betty and Barney Hill described their ordeal, they weren't just recounting an event, they were giving voice to a universal question: what if we're not alone? And what if those others aren't friendly? These tales, whether rooted in reality or the subconscious, remind us that the search for extraterrestrial intelligence isn't just about science. It's about storytelling, too, the way we try to make sense of the vast, mysterious universe around us. So while abduction accounts may not hold up under scientific scrutiny, they endure as cultural touchstones. They're modern myths, born from the same human impulse that once filled the night sky with gods and monsters, and in that sense, they're just as valuable. They show us how the unknown sparks creativity, fear, and wonder, all essential parts of being human. As we continue to scan the cosmos for signals, it's worth remembering that sometimes the most alien thing out there might just be our own minds. But let's turn from the shadows of our own minds to the stories we've crafted about the stars. Science fiction has long been a mirror, reflecting our hopes and fears about what, or who, might be out there. From the panic-inducing radio broadcast of War of the Worlds in the 1930s to the thoughtful cosmic whispers of Contact, fiction has shaped how we imagine extraterrestrial life. These stories don't just entertain, they train us to think about the possibilities, both thrilling and terrifying. Consider how often aliens appear in pop culture as either saviors or invaders. Films like Independence Day play on our fears of the unknown, while E.T. tugs at our longing for connection. Even the sleek, enigmatic beings of Arrival challenge us to think about communication in ways science is still grappling with. These narratives don't just spring from nowhere. They are rooted in the real questions scientists ask. What would alien technology look like? How would we bridge the gap between species? Fiction takes these ideas and runs with them, sometimes stumbling into absurdity, other times landing eerily close to plausibility. Yet there's a delicate line between inspiration and misconception. While sci-fi sparks curiosity, it can also set unrealistic expectations. Hollywood's faster-than-light travel and instant translators are thrilling, but they are shortcuts, not blueprints. Real science moves slower, testing hypotheses and sifting through data. But that doesn't mean fiction and science are at odds. Many astronomers and SETI researchers admit their childhood love of Star Trek or the X-Files guided them toward their careers. Imagination, after all, is the first step toward discovery. So the next time you lose yourself in a sci-fi epic, remember, Those stories are more than escapism. They're part of a conversation humanity has been having for centuries, one that blends wonder with rigorous inquiry. Whether through novels, films, or late-night stargazing, we're all participants in the grand, ongoing story of the cosmos, and the question of who else might be out there, waiting in the dark. Now, let's drift into one of the most fascinating puzzles in the search for extraterrestrial intelligence. How would we even talk to them? Imagine standing on a cosmic shoreline, tossing a message in a bottle into an ocean of stars, hoping someone, or something, might find it. That's essentially what we've been doing for decades. Take the Arecibo message, for example. In 1974, scientists beamed a radio signal from the Arecibo telescope toward a star cluster 25,000 light-years away. It was a simple, binary-encoded picture, a stick figure of a human, our DNA helix, even a crude diagram of our solar system, a fleeting hello to the cosmos, sent with no guarantee of a reply. Then there's the Voyager Golden Record, a literal time capsule strapped to spacecraft, now drifting beyond our solar system, etched with sounds of Earth, from Bach to whale songs, from greetings in 55 languages to the laughter of children. It's a snapshot of humanity, meant to outlast us. But here's the catch. These messages assume aliens think like us. What if their senses or language are utterly alien? Light or sound might mean nothing to them. They could communicate through chemical signals, magnetic pulses, or something we can't even conceive. Even mathematics, often called the universe's universal language, might not translate. Our 2 + 2 = 4 could be as baffling to them as their version would be to us. And then there's time. The Arecibo message won't reach its target for millennia. By then, will we still be here? Will they? It's a conversation where each word takes generations to arrive. Yet, despite the odds, we keep trying. Because if we ever do make contact, the first challenge won't be technology, it'll be understanding. Not just decoding their message, but grasping what it means to share a universe with minds utterly unlike our own. So as you gaze up tonight, think about those cosmic letters in a bottle, sailing through the void. They're more than science, they're hope, cast in radio waves and gold-plated copper. A whisper across the dark, asking, is anyone out there? And maybe, just maybe, listening for an answer. Now, let's turn our gaze toward a theory that casts the cosmos in a far more ominous light. The dark forest hypothesis. Picture the universe as a vast, shadowy woodland, where every civilization is a hunter, silent and unseen, afraid to reveal its location. Why? Because in this forest, making noise could mean attracting something far more dangerous. This idea flips the hopeful search for extraterrestrial intelligence on its head. Instead of eagerly broadcasting our presence, the dark forest hypothesis suggests advanced civilizations might choose to stay hidden, fearing that any contact could lead to their destruction. After all, if another species sees us as a threat or a resource, why risk annihilation? It's a cosmic game of hide and seek, where the stakes are survival itself. Think of it like this. If you were walking through that dark forest and heard a twig snap, would you call out in greeting, or would you freeze, hoping whatever made the sound doesn't find you? That's the chilling logic behind this theory. It explains the eerie silence of the universe, not as proof we're alone, but as proof everyone is too afraid to speak. Yet here we are, shining our flashlights into the dark, sending messages and listening for replies. SETI optimism clashes starkly with the dark forest's caution. One asks, "Are you out there?" while the other whispers, "If they are, we might regret finding them." It's a tension that lingers in every radio signal we send, every exoplanet we study. So as we ponder this cosmic dilemma, remember the universe might not be empty. It might just be holding its breath, and whether that silence is a warning or an invitation, well, that's the mystery we're still unraveling. Now, let's shift our perspective to another fascinating idea that might explain the cosmic silence: von Neumann probes. Named after the brilliant mathematician John von Neumann, these are hypothetical self-replicating machines designed to explore the galaxy with almost no effort from their creators. Picture tiny, intelligent probes, no bigger than a toaster, landing on asteroids or moons, mining materials, and building copies of themselves. Over time, they could spread across the stars like cosmic dandelion seeds, quietly studying every corner of the Milky Way. What makes this concept so intriguing is its efficiency. Instead of sending massive ships with fragile living beings, an advanced civilization might deploy these probes to do the exploring for them. They'd be patient, tireless, and nearly invisible, operating on timescales far beyond human lifespans. And if even one probe reached a new star system, it could replicate, sending out dozens more, creating a network of silent observers. This raises a haunting question. If such probes exist, why haven't we found one? Some suggest they might already be here, disguised as natural objects or simply too small to notice. Others argue they could be programmed to avoid detection, observing us from a distance like unseen surveyors. It's a humbling thought that our solar system might be just another stop on a grand, automated tour of the galaxy. Yet, like the dark forest hypothesis, this theory leaves us with more mysteries than answers. Are the stars truly empty, or are we surrounded by machines too subtle to spot? The silence of the universe might not mean we're alone. It might mean we're being watched. And as we peer into the night sky, wondering who's out there, perhaps the real question is, who's already here? Now, let's consider a gentler explanation for the silence, one that doesn't involve hidden dangers or unseen machines. Imagine, for a moment, that advanced civilizations aren't ignoring us or hiding out of fear. Instead, they might be watching us with quiet curiosity, like scientists observing animals in a vast cosmic zoo. This is the heart of the zoo hypothesis, a theory that suggests extraterrestrial beings could be deliberately avoiding contact to let humanity develop naturally, without interference. Think of it like a wildlife preserve. Just as we protect endangered species by limiting human interaction, a highly advanced civilization might see Earth as a fragile ecosystem of culture and biology, something to be studied from afar. They could have strict rules against making their presence known, fearing that sudden contact might disrupt our social evolution or technological progress. After all, history shows how encounters between advanced and less advanced societies often end badly for the latter. What's striking about this idea is its optimism. Unlike the dark forest's paranoia or von Neumann's cold automation, the zoo hypothesis paints aliens as patient, ethical observers. They might be waiting for us to reach a certain milestone, perhaps the discovery of interstellar travel or global unity, before they reveal themselves. Or maybe they're simply content to watch, learning from our struggles and triumphs without ever stepping in. Of course, this raises its own questions. How would we ever know if we're being watched? Could their surveillance be so perfect that we'd never spot it? And if they're out there, silently guiding or guarding us, what does that mean for humanity's future? The zoo hypothesis doesn't answer these mysteries, but it offers a comforting thought. The universe might not be indifferent to us. It might just be giving us room to grow. As we ponder this possibility, the night sky feels a little less empty. The stars could be full of eyes, quietly waiting for the day we're ready to meet them. And until then, perhaps the greatest proof of their presence is the very silence they've chosen to keep. Now, let's shift our gaze from passive observation to the cutting edge of cosmic communication. What if the silence we perceive isn't a lack of interest, but a limitation of our own technology? Enter the realm of quantum communication, where the bizarre rules of the quantum world might hold the key to unlocking interstellar dialogue. Picture this: two particles, separated by light years of space, somehow linked in a way that defies common sense. This is quantum entanglement, a phenomenon Einstein famously called spooky action at a distance. When one particle's state changes, its entangled partner instantly reflects that change, no matter how far apart they are. For scientists dreaming of talking to distant civilizations, this could be the ultimate cosmic telephone line. Imagine an advanced alien race encoding messages in these entangled particles, sending information faster than light, something impossible with our current radio signals. No more waiting centuries for a reply. A question whispered to the stars could receive an answer in the blink of an eye. It's a tantalizing thought, one that blends hard physics with the poetry of connection. Of course, the challenges are staggering. Maintaining entanglement across interstellar distances would require technology far beyond ours, and decoding such messages would demand an understanding of quantum physics we're only beginning to grasp. But if civilizations millions of years ahead of us have mastered this, their conversations might be humming silently through the fabric of space, invisible to our clumsy instruments. This isn't just science fiction. Labs on Earth are already experimenting with quantum communication, sending encrypted messages across cities using entangled photons. While we're light years away from galactic Zoom calls, these tiny steps hint at a future where the universe's greatest conversations happen not with radio waves, but with the ghostly whispers of quantum particles. So the next time you feel the universe is too quiet, remember, the stars might be buzzing with chatter we simply lack the ears to hear, and perhaps one day we'll crack the quantum code and find the cosmos has been speaking to us all along. But let's step back for a moment and consider the sheer scale of the challenge. Even if we could send or receive messages at the speed of light, the universe operates on a timeline that dwarfs human lifetimes. Picture a single beam of light leaving Earth today, racing toward the nearest star, Proxima Centauri. By the time it arrives 4 years from now, how much will have changed here? Now imagine that same signal traveling to a galaxy millions of light years away. The message would outlast civilizations, crossing distances so vast they defy comprehension. This is the quiet tyranny of space and time. The stars we see tonight aren't as they are now, but as they were decades, centuries, even millennia ago. Their light is a postcard from the past, carrying whispers of events long before humans walked the earth. And if another civilization is gazing back at us, they might be seeing dinosaurs roam or ancient cities rise, with no way to know we're here now, reaching out to them. Yet there's a strange beauty in this cosmic delay. It forces us to think in terms of generations, not minutes. A message sent today might be received by beings whose grandparents hadn't yet been born when it left our planet. Our attempts to connect become time capsules, cast into the void with no guarantee of reply, but with the hope that someday someone will listen. This patience is woven into the fabric of the universe itself. Stars are born and die over epochs. Galaxies dance in slow motion, and the search for extraterrestrial intelligence becomes less like a conversation and more like planting a tree whose shade you may never sit under. But that doesn't make the effort any less meaningful. After all, the universe has all the time in the world, and perhaps so do we. But as we ponder the vastness of space and the patience required to search for life beyond Earth, let's turn our gaze closer to home, to the tiny, unassuming creatures that might hold the key to understanding life's potential across the cosmos. Astrobiology, the study of life in the universe, often begins right here on our own planet, in the most unexpected places. Take tardigrades, for example. These microscopic beings, often called water bears, are among the hardiest life forms we've ever discovered. They can survive extreme cold, scorching heat, crushing pressure, and even the vacuum of space. Freeze them, boil them, or blast them with radiation, they'll simply curl up, enter a dormant state, and revive when conditions improve. If life can thrive in such hostile environments on Earth, why not elsewhere? These resilient creatures challenge our assumptions about where life might exist. If tardigrades can endure the harshness of space, could similar organisms cling to existence beneath the icy crust of Europa or in the methane lakes of Titan? Astrobiologists study these extreme environments, deep sea vents, acidic hot springs, arid deserts, to map the boundaries of life's adaptability. Each discovery expands the list of places we might find life beyond Earth. And it's not just about survival. Tardigrades and other extremophiles hint at the sheer creativity of evolution. Life, it seems, finds a way even in conditions we once thought impossible. This opens the door to imagining organisms unlike anything we've seen, thriving in alien atmospheres or metabolizing chemicals we'd consider toxic. The more we learn about life's tenacity on Earth, the more we realize the universe could be far more alive than we ever dared to dream. So while we scan the stars for signals or search distant planets for signs of civilization, let's remember the humble lessons from Earth's toughest survivors. They remind us that life, in all its forms, is both fragile and astonishingly resilient, a whisper of possibility echoing across the cosmos. Now, Let's shift our focus from the microscopic to the monumental, not in size, but in scale of human collaboration. One of the most inspiring chapters in the search for extraterrestrial intelligence isn't just about scientists with telescopes. It's about ordinary people, like you and me, joining forces in a global effort. Enter SETI at Home, a project that turned millions of personal computers into a virtual supercomputer, all working together to sift through the cosmic static for signs of intelligent life. Imagine this. While you slept, your laptop could have been scanning radio waves from distant stars, crunching data in the background. That's exactly what SETI at Home allowed. Launched in the late 1990s, it harnessed the unused processing power of volunteers' devices worldwide, creating a network far more powerful than any single observatory. Every participant became a silent partner in the search, their machines parsing faint signals that might otherwise have gone unnoticed. This wasn't just about technology. It was about hope, a shared belief that humanity, collectively, could uncover something extraordinary. Over 5 million people joined the effort, donating billions of hours of computing time. Think about that, a global community, united not by borders or languages, but by curiosity and the thrill of possibility. Even if no definitive signal was found, the project proved something profound. The desire to answer the question, "Are we alone?" transcends laboratories. It lives in living rooms, dormitories, and coffee shops, anywhere someone chose to contribute a slice of their machine's power to the cosmos. SETI at Home also reshaped how science could be done. It pioneered the concept of citizen science, showing that breakthroughs don't always require elite institutions. Sometimes, they just need a crowd of willing participants, each adding a tiny piece to the puzzle. Though the original project ended its day, a collection in 2020, its legacy endures. It reminded us that the search for extraterrestrial intelligence isn't just a scientific endeavor, it's a human one. And so, as we look to the stars with ever more advanced tools, let's not forget the quiet power of collaboration. Whether through a telescope or a laptop, every effort, no matter how small, brings us closer to the day we might finally hear a whisper from the cosmos. Now, let's take a moment to appreciate the humor and humility woven into the search for extraterrestrial intelligence. Even the most serious scientific endeavors have their share of false alarm signals that initially seemed like potential greetings from distant civilizations, but turned out to be something far more ordinary. These false positives remind us that the cosmos is full of surprises, and not all of them come from beyond Earth. One of the most famous examples happened in the late 1990s, when researchers at a SETI facility detected a strong, repeating signal that seemed too perfect to ignore. Excitement spread quickly until someone realized the rhythm matched the timing of a microwave oven in the break room. Every time a scientist heated their lunch, the telescope picked up the burst of radiation. It was a cosmic case of dinner time interference, proving even the search for aliens can't escape the mundane realities of human life. Then there was the case of the mysterious space chirps that baffled astronomers for years. These brief, high-frequency signals appeared to come from deep space, sparking theories about advanced alien technology. But the truth, they were the echoes of satellites, their solar panels flexing as they moved in and out of sunlight, creating tiny vibrations that mimicked extraterrestrial transmissions. It was a reminder that our own technology often whispers back to us in ways we don't expect. These stories aren't just amusing anecdotes. They highlight the incredible care scientists take to verify every potential signal. Before announcing a discovery, researchers must rule out countless earthly explanations, from aircraft radar to cell phone towers, even the occasional passing truck with a faulty radio. The process is painstaking but necessary. After all, claiming contact with an alien civilization is perhaps the biggest announcement humanity could ever make. It demands absolute certainty, so while false positives might feel like setbacks, they're actually proof of something remarkable. They show how rigorously science operates, how patient we must be in separating cosmic whispers from human noise. And who knows, the next time a strange signal appears, it might just be the one that changes everything. Until then, we keep listening, testing, and laughing at the universe's little jokes along the way. Now, let's step into a moment that has captivated human imagination for centuries, the day we finally receive undeniable proof that we are not alone. Picture the announcement echoing across the globe, rippling through every culture, every belief system, every individual. The confirmation of extraterrestrial contact wouldn't just be a scientific breakthrough, it would redefine what it means to be human. At first, the reaction might be a mix of awe and unease. Some would feel a profound sense of unity, realizing that our petty divisions pale in comparison to the vastness of the cosmos. Borders, conflicts, and ideologies could suddenly seem smaller as we grapple with the idea that we're part of something infinitely larger. Yet alongside that unity, there would likely be fear, the natural hesitation toward the unknown. Would these beings be peaceful? Would they see us as equals or as something lesser? History tells us that encounters between civilizations rarely unfold without tension, and this would be no ordinary meeting. But fear wouldn't be the only response. Curiosity would ignite like never before. Scientists, artists, philosophers, everyone would hunger to understand what this means for our place in the universe. Religions might reinterpret ancient texts, while governments scramble to establish protocols for communication. The discovery could spark a new era of collaboration, as humanity pools its knowledge to decode alien languages or technologies. And then there's the quieter, more personal impact. Imagine looking up at the night sky, knowing with certainty that someone or something is looking back. That simple realization could shift how we see ourselves, our planet, and our future. Of course, not everyone would react the same way. Some might dismiss it as a hoax, clinging to skepticism even in the face of evidence. Others might see it as a spiritual sign, a call to evolve beyond our current limitations. But one thing is certain, contact would dissolve the line between science fiction and reality, leaving us to navigate a world where the impossible has become truth. Perhaps the most beautiful outcome would be the way it reminds us of our shared humanity. In the face of the cosmic unknown, we'd have no choice but to confront our collective hopes, fears, and dreams. Whether it brings harmony or discord, the discovery of extraterrestrial intelligence would ultimately hold up a mirror, showing us who we truly are and who we might yet become. And as we ponder that possibility, we're left with one final thought. The universe has been silent for so long, but if it ever speaks, will we be ready to listen? Now, let's turn our gaze inward to the questions that lie at the heart of human existence. The discovery of extraterrestrial intelligence wouldn't just reshape science, it would ripple through the very foundations of our beliefs, both religious and philosophical. For centuries, faith traditions have offered answers about humanity's place in creation, often centering Earth as unique and divinely chosen. But what happens when we're no longer the only ones in the cosmic story? Some might see this as a challenge, a moment where ancient texts and teachings must be reinterpreted. If life exists beyond our planet, does that diminish our significance, or does it expand the tapestry of meaning? Many theologians and spiritual leaders argue that the existence of other beings could deepen our understanding of the divine, revealing a universe far more vast and mysterious than we ever imagined. Rather than threatening faith, it might invite us to see sacred writings as part of a larger, still unfolding narrative. Philosophically, the implications are just as profound. Questions about consciousness, morality, and the nature of existence would take on new dimensions. Are concepts like right and wrong universal, or are they shaped by the peculiarities of human evolution? If we encounter beings with entirely different histories, environments, and ways of thinking, we might discover that truth itself is more fluid than we assume. Yet this isn't a crisis, it's an invitation. The universe has always been bigger than our understanding, and the possibility of alien life simply reminds us of that humility. Instead of fearing the unknown, we might embrace it as a chance to grow, to question, and to marvel at the sheer diversity of existence. After all, isn't wonder itself a kind of faith, a recognition that there's always more to discover, more to learn, more to cherish? So as we ponder these cosmic questions, let's not see them as walls to fear, but as doors to walk through, wide open, with curiosity as our guide. And with that thought, we drift toward another mystery waiting in the stars. But for now, let's turn our imagination toward the stars not just as distant points of light, but as destinations waiting to be reached. The dream of interstellar travel has long captivated humanity, and while the challenges are immense, the possibilities are as vast as space itself. One idea that sparks the imagination is the concept of warp drives, inspired by the very edges of our understanding of physics. Theoretically, a warp drive could bend space-time itself, creating a bubble that moves faster than light without breaking Einstein's cosmic speed limit. It's a tantalizing thought, slipping through the fabric of the universe, not by pushing against its limits, but by folding them. Though still speculative, the math suggests it's not entirely impossible, leaving room for hope that one day we might traverse the galaxy in ways that feel like science fiction today. Then there are generation ships, colossal vessels designed to carry entire communities across the centuries, long void between stars. Picture a self-contained world, where families are born, live, and pass on the mission to descendants who will one day arrive at a new home. It's a slower journey, but one that mirrors the patience of the cosmos itself. These ships would be more than just technology. They'd be floating civilizations, carrying not just people, but cultures, stories, and dreams into the unknown. And what about light sails, propelled not by fuel, but by the gentle pressure of starlight, or cryogenic sleep, where travelers might slumber through the millennia, waking only when their destination shines bright through the viewport? Each idea is a thread in the tapestry of human ingenuity, woven from equal parts science and wonder. The truth is, interstellar travel demands more than just engineering. It requires a shift in how we think about time, distance, and our place in the universe. Whether we're bending space-time or sailing on beams of light, these dreams remind us that exploration is never just about reaching a place. It's about carrying the essence of who we are into the cosmos, one bold idea at a time. So as you drift into sleep tonight, let your mind wander among these far future journeys. Who knows, the very dreams we weave today might one day become the blueprints for humanity's greatest adventure. And with that thought, we gently turn our gaze to another mystery, the silent, waiting cosmos, and what its quiet might truly mean. Yet, amid all these dreams of reaching the stars, there's something haunting about the silence that greets us when we listen. The universe is vast beyond measure, filled with countless stars and planets, and yet, when we point our telescopes and radios toward the heavens, what we hear is mostly nothing, a quiet so deep it almost feels deliberate. This cosmic silence is what scientists call the Great Silence, and it's one of the most puzzling aspects of our search for extraterrestrial intelligence. With so many worlds out there, why haven't we picked up a single unmistakable signal? Why does the universe seem so empty, even when the math suggests it shouldn't be? Some say it's a matter of time, that we've only just begun listening, and patience is key. Others wonder if the silence itself is a message, a clue to something we don't yet understand. Perhaps civilizations are rare or fleeting. Maybe they're out there but choose not to broadcast, hiding in the cosmic dark for reasons we can't yet fathom. Or it could be that the distances are simply too vast, and signals fade into the background noise before they ever reach us. There's even the unsettling possibility that advanced societies tend to self-destruct before they can spread among the stars. But here's another way to think about it. What if the silence isn't eerie at all? What if it's peaceful? The universe isn't empty. It's full of wonders we're only beginning to uncover. The quiet might simply mean we're early to the party, or that life is rarer and more precious than we imagined. Either way, the mystery invites us to sit with the unknown, to embrace the questions as much as the answers. So as you drift off tonight, let the quiet of the cosmos settle around you. There's comfort in the mystery, a reminder that some things are meant to unfold in their own time. And who knows, maybe one day the silence will break and the universe will finally whisper back. Until then, the stars keep their secrets and we keep listening. Now, as we turn our gaze to the horizon of discovery, the future of the search for extraterrestrial intelligence shines brighter than ever. New tools are on the way, instruments so powerful they might finally crack the cosmic silence wide open. Take the James Webb Space Telescope, for example, already peering deeper into the universe than ever before, studying the atmospheres of distant exoplanets for hints of life. But that's just the beginning. Soon, the Square Kilometer Array will come online, a network of radio telescopes spanning continents, with the sensitivity to detect even the faintest whispers from civilizations light years away. These aren't just upgrades, they're leaps forward, giving us eyes and ears sharper than anything we've had before. Imagine sifting through the static of the universe and finally catching a pattern, a signal that doesn't just fade into the noise. It's not science fiction anymore. We're building the machines that could make it reality. And it's not just about hardware. Scientists are refining their methods too, searching for technosignatures, clues like industrial pollution in alien atmospheres, or the heat signatures of massive energy projects. Even the way we process data is evolving, with artificial intelligence helping to scan the skies faster and more thoroughly than any human team ever could. So while the universe has been quiet so far, the next chapter of SETI is anything but silent. It's a symphony of innovation, a chorus of new ideas and technologies all working toward one question: are we alone? The answer might be closer than we think, and when it comes, whether it's tomorrow or decades from now, that moment will redefine humanity's place in the cosmos. Until then, we keep building, keep listening, and keep hoping, because the stars have stories to tell, and we're finally learning how to hear them. But before we close this cosmic journey, let's take a quiet moment to reflect. Picture yourself under a vast, starry sky, the same sky that has sparked wonder in countless generations before us. What does it mean to be part of a universe so immense, yet so silent? If we one day hear a voice from the stars, how would it change the way you see yourself, or the tiny blue planet we call home? Perhaps the search for extraterrestrial intelligence isn't just about finding others. Maybe it's also about understanding ourselves, our curiosity, our loneliness, our boundless hope. Every signal we send, every telescope we build, is a testament to that hope. A whisper into the dark saying, "We're here, are you?" And if the answer never comes, the search itself still matters. It reminds us that we're part of something grander, a story written in starlight. So tonight, as you drift toward sleep, let the quiet vastness of space cradle your thoughts. Whether we're alone or not, the universe is listening, and so are we. Sweet dreams, and may the stars whisper their secrets to you. As we bring our journey through the cosmos to a close, let's take one last look at the path we've traveled. From the early days of radio telescopes, straining to catch a whisper from the stars, to the cutting-edge projects scanning millions of galaxies today, the search for extraterrestrial intelligence has always been a dance between science and wonder. We've pondered the silence of the universe, marveled at distant exoplanets, and even dared to imagine civilizations far beyond our own. Yet through it all, one truth remains: the search itself is what binds us to the stars. Whether we ever find an answer or not, the act of reaching out into the void speaks volumes about who we are. It's a reminder that curiosity and hope are woven into the fabric of humanity. So as you settle into the quiet of the night, let the vastness of space fill you with awe, not loneliness. The universe may be silent for now, but the search continues, and with it, the promise of discovery. Sweet dreams, and may the stars whisper their secrets to you.